Hello, my name is Cephas Bonachi, and in this video, we'll be going to talk about bias and variance. I know most of you have been wondering what is the difference between bias and variance. So, as you know, in this video, we'll be using linear regression. As you know, there are many types of linear regression. There's a multiple linear regression, there's a polynomial linear regression. But in this video, we'll be going to use the polynomial linear regression. As you know that linear regression creates a best fit line creates a best fit line. So for example, in this one, the x's is referring to the actual data sets, actual points, but the line here is a best fit line. Okay, as you can see, in the first one, the degree of polynomial is 1. In the second one, the degree of polynomial is 2. Third one, the degree of polynomial is equal to 4. So when we come to the first one, as you can see, these points, the actual points are far away from the predicted points. So you can say that the R-squared error is very high in this one. But in the fourth one, you can see that these points are exactly fitted. This is the condition where each point is exactly fitted to the line. So in this third one, we can say that this condition is overfitted. I'll tell you what overfitting means. In the first one, this condition we say that it is underfitted. Underfitting. Okay, what underfitting means, like in these diagrams, it is with respect to the training data sets. Okay, what underfitting means is that it has a high error in the training dataset and also a high error in the test datasets. Since this is in regard to the training datasets, when we give maybe a new dataset like this one, let's create some x's, the new x's. So we'll see that in the training dataset, there will be a high error. But in the test dataset, there will also be a high error. As you can see, there will also be a high error. So we'll say that when there is a high error in the trained dataset and a high error in the test dataset, we'll say that this condition is underfitted. Let's go to the fourth one. We have said that this diagram is with respect to the training dataset, and as you can see that each point is exactly fitted to the line, or in other words, we can say that when our model is performing very good in the training dataset, we will say that this condition is overfitted. So in case we have our new datasets, let's say our new datasets, which are the test datasets here, you can see that there's a difference. There's a high error between this actual and the predicted. The predicted is this line. So we'll say that this condition with a degree of polynomial is equal to 4. It is overfitted since it is performing very good in the training dataset, but when we introduce new data points, which is the test dataset, it is performing poorly. We have a high error. So this condition, we say that it is overfitted. Okay. In regards to bias and variance now, let's come to the first one. The first one will say that it has a high bias and high variance. The best way to interpret this is that bias is an error of the training dataset. Okay? The variance is the error of the test datasets. And we have seen that in our first one, where the degree of polynomial is equal to 1, this one had a high error in the training dataset, and also when we introduced the test datasets, it also had a high error. Now we'll say that this condition has a high bias and high variance. Okay, let's go to the fourth one. We'll say that this one, since it had a low error in the training dataset, since this condition is where each point was exactly fitting to the line, as you can see it. So it had a low error in the training dataset. So we'll say that, and we have said that bias means that it is an error of the training dataset. Since this one has a low error in the training dataset, we'll say that it has a low bias. But in the test dataset, when we introduced the new points, which is the test dataset, it had an error, a very high error. So we'll say that it has a high variance. Okay? Now let's come to this one. The degree of polynomial is equal to 2. This one has a low error in the training dataset. When we introduce new points, it is almost fitting to this line. So in the training dataset, as you can see with the blue marker pen, it has a low error in the training dataset and also a low error in the test dataset. So we'll say that this one has a low bias and high variance. Okay, that was regards to regression problem. Let's go to the classification problem now. Classification problem, let's say we have a model 1 here, model 2 here, and model 3. So in model 1, we see that it has a train error of 2% and a test error of 23%. Since this is our model 1, and what I mean by classification problem is maybe when you have a model that is predicting maybe a male or a female. If it is a male, it's classifying it as 1. If it is a female, it's classifying it as 0. So we call that one a classification problem. So in model 1, it has a training error of 2% and a test error of 23%. Training error of 2% is a very low error. Since it's a very low error, we'll say that it has a low bias. A low bias means a low error in the training dataset, as we have seen. And a high variance is an error of the test datasets. Since it has a high error of 23%, we'll say that it has a high variance. Okay, let's go to model 2. Model 2, the training error is 5%, the test error is 7%. As you can see that these errors are very small. They are less than 10%. You can say that they are less than 10%. Since the training error and the test error are less than 10%, we'll say that it has a low bias and low variance. Our model 3 here, it has a training error of 25 and a test error of 24%. This one, when we have a training error of 25%, it means it has an accuracy of 75%. An accuracy of 75%, it is not like the model is performing very good. You can do some hyperparameter tuning to increase the accuracy. So still, we can say that this error is very high. So if the error is very high, we'll say, if the training error is very high, we'll say that it has a high bias. And if the test error is also very high, say that it has a high variance. Okay, let us do the graphical representation of this. The graphical representation of that, let's draw this way. Degree of polynomial. Okay. This is the error with respect to degree of polynomial. Okay, when our degree of polynomial, when it was 1, this one, when it was 1, it had a high error in the training datasets. Okay, since it has a high error, we put it there, put it as star. What about it has a high error in the training dataset? What about in the test dataset? It also had a high error in the test dataset. We'll mark it with the black pen. Let's go to the one with the degree of polynomial is equal to 4. The degree of polynomial is equal to 4 will be around here. The degree of polynomial is equal to 4. It means it has a low bias, a low error in the training dataset. So a low will be here, down here. You can see the error is here, so it will be having a low error in the training dataset. But in our test dataset, it is having a high variance, which means it has a high error in the test dataset. So we'll mark it with a black pen here. If we join them, it will be like this. This one will come like this to a certain point here, then it starts rising again. Okay, this point here, this is a point where we have a low bias and low variance. So we can say that these are generalized model. And these are model we need to be using. A model which has a low bias and a low variance. Maybe to talk a little about the decision tree and random forest. Decision trees, they are normally said to be having, they are overfitted. Yeah, they are normally said to be overfitted. And in our next video, we'll see why they are normally referred to as overfitted models. And the way to reduce that, there are various ways you can do, maybe by pruning the decision trees or by using random forest. And by random forest, you are reducing the low bias, this one. You are reducing the high variance into, you are reducing this high variance into low variance. So by doing that, you will have sorted the overfitting condition. So see you in the next video.